Okay, gentlemen, this is what I got working tonight. So when it starts up, it goes through the boot process and the connection process, and then it gets to this. In fact, let me just restart the whole thing. So booted, connected, smiley face, that means it's on the network. And then if it connects to internet, it does that, and then, so it's on the internet. And so it uses the sensor 0 and sensor 1, starts off default. So if I press the button, it turns on the temperature. It's 24, and let's see if I grab it. Should go up. Maybe I'm grabbing the wrong one. Let's try this one, temperature 0. Yeah, so I grabbed the wrong one, 25, 25.5, 26. It updates for, let's see, I think 5 times a second or four times a second, somewhere in there. So it gets up to 28. Then I can turn the other one off so they can both be on at the same time. It said 25, 8.5. Let's see if it goes higher. Yeah, so it goes higher without the other one going higher and without anything to absorb the energy. So it's going higher, the other one's staying where it is, and it's actually going down a little bit. It only has half of a decimal place in precision. So anyway, but within body temp, we can get tests to test them out, but if I press that, it turns the other one off. So that's working right now. Because of the limitation, it's best to just have it reading constantly in the background and only sending it to the server if the sensor is active on a new read. So that'll be the logic that handles that. Cody is going to need to take care of the reconnect logic. So the thing is, the two sensors could be hot swapped at any time, so there's got to be logic for that. I'm going to generate a ChatGPT summary of everything that I had ChatGPT tell me about it, and I'm going to have it generate a prompt and then enter that prompt into GPT. So it's kind of weird getting GPT to create a GPT conversation for me. Inception. So yeah, that's where it's at right now. And then this button right over here will reset the Wi-Fi credentials. I think that's valid to have in case you know, I guess it won't really come up for most of the time that we have it, but yeah, it's just there for an emergency, so that if you get in the case where there's two Wi-Fi networks in the same area that you've connected to and you want to switch from one to the other, the current method won't let you do that, or the current way it's set up won't let you do that. So yeah, and then they're both off. It's still taking temperatures in the background, and the reason for that is the temperature has to be available right within the button being pressed. And the thing is, if the sensor was never active prior to the button press, you would have to wait until there's data available, which is going to take at least 100 milliseconds. So that's longer than the 20 millisecond window. And Cody brought this up. So the best way to do it is just have temperatures constantly in the background. So you've got a most recent temperature that you can display and just update it as you have. But the code right now basically has these semi-asynchronous behavior where it just has time guards to check to make sure that the certain events don't happen too often, and it has like a non-blocking behavior all throughout so that it can read the button states as quickly as possible. And yeah, that's the way to do it locally. So what we'll do is anytime the button state changes, we'll send that off to the server, and then that will send to the clients. And when the clients connect, it'll get the button states from the server, I guess. We'll see what the best way to handle that is. Yeah, it'll probably just be mitigated through the server. And then, yeah, but the next two things, at least from the local end, would be to handle the reconnection so it's robust. There's a way to do it. It's a little involved, but it's a few lines of code. It does have to be incorporated in logic. The code is also spaghetti code, so it could be refactored and packaged into simple modular functions, assuming that the values are either passed in or they're global, one of the two. And yeah, apart from that, the next thing I'm going to work on is just, now that this is a base, and this is a working model, so we could do a pull request. I can show you guys how to do that tomorrow. And but this is a working code that could supplant the existing code base. The only difference is that the IP addresses aren't, but when I put it into main, I'll make sure that the IP addresses are resolved the way that they're normally resolved in a pinch, in the more versatile way, but that isn't quick for home debug if you're trying to switch between multiple people developing on the server, or using the server at one time, replacing the DNS address. So yeah, that's everything as far as where it's got, but I got to set things to an okay standpoint. Tomorrow I'm going to focus on getting this code into the ring buffer in the server, and then sending the ring buffer over to the clients when they connect. So that's what I'll mainly be working, and also syncing up Matt's code with this. But once I get data being sent to the server, we'll go from there. But everything's going to have to go in JSON, because we can't do, JSON has a lot of padding, so it formats things with extra control characters to tell you how the data is structured. That can eat up an extra like 30 to 40% of your data, or it can be 30 to 40% higher, so 140% of the size. And Uvicorn, or rather, yeah, Uvicorn for Fast API has a limit on how big messages can be, so you'd have to chunk them if you couldn't send them all in one go. And anyway, it's 1 megabyte, and so I had GBT do the math, and it's like a tenth of that is what we currently have if we're sampling 4 times a second, which seems to be a pretty good rate. We'll do that as a target so that the graph grows realistically and smoothly, or as smooth as 4 times a second can be. There might be a little jitter. It won't be as good as 10 times a second, but 10 times a second would still be compliant, but we'll get it working there. And if we have time, it'd just be modifying a few lines of code to get everything working in the quicker sample size. We can go up to 10 per second, however, because the manufacturer guarantees that the temperatures can read once every 96 milliseconds. Like, that's the guaranteed. Like, it'll be less than that, but within that time you'll be guaranteed a resolved temperature. So yeah, I'll send this out to you guys.